Hello guys, welcome back. In this today's class we will see how to design the 1:4 demultiplexing operation, right? So what is the meaning of 1:4 means? 1 means single input which we are going to convert in terms of the 4 output, means we are going to perform the data distribution operation. Data distribution operation means if you consider, so how many inputs, right? The output of the multiplexer is the nothing but the input of the demultiplexer. So single input I, it means that inside of this one we will be having the I0, I1, I2, I3 values, right? So how many outputs we will be having? So 1 to 4 demultiplexer, right? So how many outputs we will be having? Let it be D0, D1, D2, D3, whatever it may be. It may be Y0, D0, whatever it may be. Now how many selection lines are required for 4 possibilities? 2 power 2, right? So it means that 2 selection, right? So I am considering the S0, S1 are the selection line. Once it is done, what is the next step? We need to draw the truth table representation, right? So in the truth table we will be having the input values, then one more is the output values. How many outputs we have here? If you observe here, D0, D1, D2, D3 are the output values, right? Now how many inputs values we have? So selection lines S0, S1, then one more is the I, right? So remember guys, this I is constant value, right? This I is the constant value, single input, right? So always this value will be same only, I, something like this, right? Now how many selection lines we have? 2, right? How many possibilities we will be getting? Either it may be 0, 0, 0, 1 or 1, 0 or 1, 1. So just I am writing these possibilities. So just I am writing these possibilities. Now it is done. Now what will be happen? When your selection line value equal to 0, 0, what is our output value? 0, 0 means 0, right? Which means that D0 will be activated. You think in terms of D0 is the decimal number. So D0 will be activated. Activation means, remember guys, activation means at a time out of these 4 possibilities we will be getting only one output at a time, remaining all will be zeros. It means that at a time we can able to activate it only single output. It means one activated means remaining all should be deactivation mode, right? Which one is activated? D0. Activation means we are writing 1, deactivation means we are writing the 0, right? So it means that D0 equal to 1. What about this one? So these all will not be activated because your selection line equal to 0, 0. The activation of the output will be D0. Now what is the selection line value now? 0, 1, right? So 0, 1 means what is the value? 1. So it means that this decimal 1 will be activated. So if it is activated, what about this one? 0, 0, 0. Next 1, 0 is means what? 2, right? So 1, 0 means 2 means which one will be activated? So D2 will be activated. Next 1, 1 means what? 3, right? So 3 means D, this 3 will be activated. So 0, 0, 0, 1, right? Now we need to find out the third step is that we need to find out the logic expression as we discussed in the previous class, right? So multiplexer, demultiplexer can be used as the logic function generator. It means that without requirement of the K-map, directly we can find out the logic expression, right? So now see that how many outputs we have. If you observe here, 4, right? 1, 2, 3, 4, right? So one is for D0, another one is for D1, D2, D3. So 4 output means we will be getting the 4 logic expression, right? So if you observe here, right, first we are going to find out the output for the D0, right? So D0 means where we have the SOP function. SOP function means representation of the output equal to 1, right? So this is the 1, right? So for this one we need to write the input value. What is that input value? So I into 0, 0 means, right? So I into, how we can write? 0 means S0 bar, right? So again 0 means S1 bar, right? So we'll consider like this. So S0 bar, S1 bar, right? So what is the output value of the I into S0 bar? S1 bar is the output value. Once it is done, next we will try to find the output for the D1. So D1, what is the SOP function? This one, right? So what is the input value? I into 0, 1, right? So I into 0, 1 means what? So I into S0 bar S1, right? So I into S0 bar S1. So next D2 means what is this input value? This one, right? So this is the input value, right? What is that? I into S0 S1 bar. Next again for D3, this one, right? So I into S0 S1, right? So once logic expression is completed, the next step we need to draw the circuit diagram representation, right? So circuit diagram means, if you observe here, how many input variables we have? I is there, then S0 is there, one more is the S1 is there. If you observe, again S0 we have the complement value, again S1 we have the complement value. It means this is S1 bar, this is S0 bar. We are not considering the complement for I, because I we don't have the any I bar, right? So what is the first expression? I into, right? So S0 bar S1 bar, right? So S0 bar S1 bar, which logic gate? AND gate. So this is nothing but I into S0 bar S1 bar. So this is the output for the D0. For what is the D1 output? I into, right? So S0 bar, this one, this second line is the S0 bar, so S1, which logic gate? Again this is the D1. So like that for D2, I into, right? So this is S0, then one more is the S1 bar. So this is for D2. Finally, so I into S0 into S1. So this is for D3. So this is I S0 S1, nothing but this one. So I into S0 S1 bar, I into S0 S1, right? So this is how we are going to design the 1:4 demultiplexing operation, right?